Hi, y'all. Okay, let's talk about the second section on our enzyme unit. This would be the properties of enzymes as well as what are optimum conditions when we're talking about enzymes. And optimum conditions typically involve temperature and pH. Those are the two that we're going to dive into. So your notes have all the properties of enzymes. Big idea when we're looking at enzymes is that and for humans, the majority of our enzymes work best at 37 degrees Celsius. We are in a British curriculum. They use Celsius temperatures, not Fahrenheit. Now, if we're in Fahrenheit, y'all know 98.6 degrees Fahrenheit, somewhere in that ballpark, is optimum Fahrenheit temperature. Learn the Celsius number, 37 degrees Celsius. 37 degrees Celsius. That's why having a fever can be very dangerous. Because as your body gets too hot, certain reactions aren't going to occur in your body because these enzymes can be what's called denatured, and we're going to talk about that term. So let's look at how temperature affects enzyme activity. So at lower temperatures, think about diffusion and how things, when temperatures increase, rapid and random movement increases. So same thing with an enzyme. You need an enzyme to come into contact with whatever it is working on. So you need that enzyme to come in contact with its substrate, with whatever it's either going to break down, build up, or completely change altogether. So when we have low temperatures, there's less movement. So not as much collision is going to occur. But you can see as temperature increases, we are going to have more successful collisions. Enzymes and substrates will meet. And ultimately, as that kinetic energy that causes all of that random movement increases, the rate of reaction for the enzyme is going to increase. We also have something called an optimum temperature. An optimum temperature is the peak of all of these graphs. So when you see these charts and you see the nice little ebb and flow of the line on this line graph, the very top point is always your optimum temperature. So you could draw a straight line down to whatever that number would be if this graph had numbers, and that would be your optimum temperature, which means the best temperature for all of this enzyme reaction to occur either in your body or in a plant or whatever species we're talking about. Now, when we get into temperatures that are too high, so you can see temperatures are increasing. This is where we're going to have, yes, more collisions, but as that temperature increases, the active site, okay, remember the enzyme has a specific shape that the substrate has to fit into. That active site is going to change shape as everything starts moving way too fast. And we've got a video that you're going to watch to see that. We call that denaturing. So when something denatures, an enzyme denatures, it changes its shape, the substrate no longer fits, and the reaction cannot occur. So at this point, when there's complete drop-off, the temperature has completely changed the shape of the enzyme, the shape of the active site. There will be no enzymatic activity because there's no more active site. There's no more place for the substrate to come in and fit, and then the reaction to occur. Okay? So similar concept, but with pH. So we can look at a similar concept, but with pH. Now, the pH of something, y'all should know your pH chart deals with, is something more acidic, is it neutral, or is it basic? So is on our chart, we have from 1 to 6 being acidic, 7 is neutral, and then 8, anything above the 7 is going to be more basic. Anything below 7 is more acidic on your pH chart. So you can see this enzyme would have an optimum pH, if we go down, at a pH of 8. All right, depending on the enzyme that we're talking about, similar with enzymes that are, if the conditions are too acidic, they can be denatured. And then moving away from optimum pH is less activity. The site becomes disordered, also being denatured. Depending on the enzyme, there may be a specific pH that the enzyme prefers. And we're really going to get into this when we talk about the digestive system. With the digestive system, we have enzymes specifically in our stomachs that are incredibly acidic because you have a ton of acid that's going to be mixed with those. And then we have certain neutralizing liquids that are going to mix with stomach acid once they exit the stomach and move on into the small intestine. So we really get to learn a little bit about enzymes and the pHs that they prefer a little bit further down the road. But for the pH, just know the crest or the peak of this little line is going to be the optimum pH. Find the number that it falls with, and just know anything below or above that, as everything is dropping off, those enzyme reactions are not occurring. Okay? All right, we'll check back in with that CFU, and then we're going to also look at some labs with enzymes.